Kovalenko. This talk, unlike the one yesterday, if you visited that, is going to be much more technical, so not as many cat pictures. The whole idea here is to, when I first started to work with Selenium Grid, I tried it for about 6 weeks, and then I gave up and threw it away. And then tried it again and then gave up and threw it away. And the whole time I was trying to figure out how to set it up, and I really enjoyed the idea, but just things were not working. And at some point I started to learn Java, and I started to learn how the grid is set up so I can improve things local at the company and make sure that things don't crash and they work as they're supposed to. But I found out that there's no documentation for Selenium Grid. There's nobody giving talks about Selenium Grid that actually explains how to do any of the basic things. And so this is the talk that I wanted. I hope it is as helpful to you as I was hoping it would be to me. Once again, I'll plug my book. So what is the Selenium Grid? It allows you to distribute, parallelize, and share resources. What does that mean? Seriously, if you try to come to somebody and say, "Hey, you should use the grid," well, what is the grid? Well, it's yeah, I don't know. So let's talk about distribute. This graphic should make a lot of sense. I just found it on the internet, but it actually means nothing. The idea, though, is to use one computer for your test suite versus using many computers for the same test suite. That's all. And the way that the grid is set up, and by the way, we will start very, very gently, and we're just going to jump into the code in a minute. So the way we set it up is you have the hub in the center, and you have a couple of nodes connecting to the hub. Each node then can declare that, hey, I have Internet Explorer 10. I can run one instance of it. I have Firefox, 3 instances, and Chrome. And then I can only run 3 tests of any combination at a time. And if you look at the config, this is where it is visible. Max instances at the bottom. This config is very important because in case of Internet Explorer, you should never have max instance of Internet Explorer more than 1, ever. The problem with Internet Explorer and Safari is that there is no concept of profiles. And so all of your history, all of your cache, all of your cookies are shared for the whole system, not for the whole system, but for the whole user. And so if you want to start 2 instances of Internet Explorer or 2 instances of Safari, you can, but they will be kind of interfering with each other, so you will not get very good, consistent results. Max session config is basically, yeah, I can run 2 instances of Firefox and 1 instance of Chrome. I typically say that if you're going to run Internet Explorer on a box, don't allow any other tests to run at the same time, even if it is Firefox or whatever, because Internet Explorer, the way it is written, it needs to have focus. And if another test starts while your Internet Explorer is running and they go on top of it, the fact that Internet Explorer is in the background, now some of the native events, such as clicks, do not function the same way you would expect them to. So if you're going to try to, one of the things that I'm trying to develop right now is have some logic where it says, hey, this node is already running Internet Explorer. Do not allow any other tests to run. If it's already running Firefox, okay, you can allow a couple other Firefoxes to run on top of it. But if it's Internet Explorer, just pretend this node is offline and send the test somewhere else. So that's something I've been working last couple of weeks. The grid allows you to run things in parallel. So if you have one test suite, now you can run 3 tests at the same time on different nodes instead of just running 1 test at a time. And the key with the hub is the session ID. That is the unique ID that you're probably familiar with when you're running tests as is. But the tricky part about the hub is it has 2 session IDs for every test. There's the internal key and there's the external key. When you first start a test and you connect to the hub, it assigns it an internal key. But not until a browser is started is the external key assigned. And that is a little bit tricky because if you're writing some Java to interact with the internals of the hub, and you're only checking for the internal key, you can have situations where, well, yeah, it looks like the session has started, but the browser actually never started. So you're going too fast. You have to stop and wait for the external key to be assigned before you move on to the next step. The grid allows you to share resources. Right now we have multiple teams. We have 3 or 4 teams using the same grid at the same time, and we don't have to have a grid for each team. That is a little bit also tricky because, as Marcus's tool shows, if one team is having a busy day and another team is having a busy day, you run into issues. And so I really want to implement and steal a lot of his code into our own grid. That way you have a little bit overflow going into when things are getting too busy. And hopefully by the end of this talk you will have enough knowledge of how the grid works so that you can actually implement it yourself if you're not waiting for me to do it. So if you want to contribute to Selenium or to the grid, or you want to poke around in the guts of the Selenium, this is the public Selenium GitHub page. Just clone it, open it in IntelliJ or Eclipse. The project file should be there and should automatically load. So, okay, now let's talk about points of extensibility. You can write some Java code to do things in the grid without actually changing the code that is from this URL. Basically, you're making local changes that will only be in your company and you can use, and nobody else can. And there's 4 or 5 instances where you can extend things. The most important one, in my opinion, are the proxies. And the proxy classes, they are quite literally what they are. When a test says to the hub, I would like to click on this element, the hub just passes on that click command to the node. So in fact, the hub is just a proxy. It's nothing. Hub is not a very magical or a smart thing. All it is a dumb proxy. And each node has an instance in memory for a proxy. That way, when a test session starts, it just uses the same thread to pass it over. And you will have multiple threads happening for each individual node. The default remote proxy is the Java class that is used for it. That is what controls the whole session starting and ending. And it has some very nice methods that you can poke around with. Just be careful. Get new session is the obvious one, and that is the method that is called as soon as the hub is trying to start a new session on one of the nodes. That one you can do some fun things and intercept some commands or add commands. If you want to, for example, restart a node after a test is done, override the after session method. That way, as soon as the node is done, you send a command to the node to just restart. Or you can, I don't know, before session you can add some proxy settings for the system, or you can throw off some files, or you can do any sort of setup that you want to do. You will be, you're allowed to override these guys and add that functionality. The trick to remember is that default remote proxy, this method, this object is on the hub. It's not on the nodes. And so if you want to, for example, restart the computer, what you will end up doing is sending the restart command from the hub to the node. You cannot just say restart, because you will restart the hub computer, not the node. So you will have to have a listener on the node that is waiting for the restart command to arrive. So basically keep that in mind at all points. Some of these, this is the project that I started that demonstrates some of the things that we'll be talking about. It does a lot more examples than what we'll talk about now. Right now, we'll talk only about video recording of a test session. But in that project, it also does, after Internet Explorer's test is done, it goes and it kills Internet Explorer just in case Internet Explorer was not killed. And then it goes and tries to kill IE-Explorer.exe or Chrome Driver.exe, etc. It moves the mouse out of the way into the corner in the before session. That way the mouse is not pointing at the Internet Explorer, because with Internet Explorer, if the mouse is in the center of the browser, it acts differently than if it's outside of the scope. So move it out of the way to have more consistent results. Things like that. So in my situation, I called it setup teardown proxy, and all it did is extended that default remote proxy that I mentioned earlier. And then I just overrode the get new session method. So we start the session once the session object is received, because on the first line of the method, the get new session command will not pass until you've received the session object. We then call the start video, pass in all the session information, and then when the video is started, we return the session to the test so you can keep going with it. This is slightly simplified because since it's Java, there's 20 more lines of code in there, but this is the basic idea of it. And some of you might ask, well, why do you need a video? Well, it's kind of a stupid question. You do need a video. And I'll give you an example, because when a test is running, you want to know what's going on. And when a test fails, you want to know why. So in my project, the video records at operating system level, not at browser level. So if Internet Explorer wants to update and there's a pop-up that says Internet Explorer is updating, and that's the reason your test failed, you will see it from the operating system level. Or when something like this happens, and all of a sudden all your tests on that node just go crazy and you do not know why. Every single time you try to send a new session command or a click command, something just goes horribly wrong each time. One bug that was driving me crazy for about 6 months is this one. There was one of the people on my team was complaining that his test would constantly break with a timeout. But it didn't make sense. It would only time out 1 out of 10 times and only on one specific page, and could not track it down and could not figure out, because I would load the page locally. It works just fine. So after recording the test itself, it turned out that in Internet Explorer 8, the JavaScript command to load the page 1 out of 10 times would start to thread and basically block the whole process. And so what Internet Explorer will do is try to block JavaScript from running. And so the page cannot load because JavaScript is not running, and JavaScript is not running because page cannot load, and the grid will sit there for 5-10 minutes waiting for the page to load, then say, hey, are you there, are you there? And nothing happens. And that little pop-up was the reason. Hey, we blocked it. So having some sort of a recording of it was extremely, extremely helpful. We can do some fun things with before and after commands. So every time a click command is forwarded, we can do some fun things on the node I'm sorry, on the hub, and pass that information to the node or somewhere else. Maybe before each command like click or before a quit command, maybe you want to update something on Jenkins or somewhere else. Well, this is a place to do it by overriding the before command or after one. And in this case, every time a command is passed, all I'm doing is notifying the video recorder what command just ran. It's similar to what Dave showed, but it does not put any objects, any JavaScript new objects into the page. So when the video is running, you can see, well, delete cookies command was just called, or click command was just called. And if the test looks like it's stuck, you can see, well, we're still waiting for the page to load. That's the command that is running. So once you have written your own class for the proxy, all you have to do is add it if you're running it from command line. Use the proxy flag for the command line argument and name the class to use. Or if you're using JSON config, you will just set it up there. So the setup and tear down proxy is right there in my config file. You have to use fully qualified Java path though, because if you just say setup tear down proxy, it will not recognize it and it will not load it into memory. But you know, it's Java. So a couple of notes about proxies though. When a node registers, the node environment does not need to have the proxy object on it, but the hub does. And at the point of the registration, this proxy line, this is from the node config. When the node wakes up and says, I would like to register to the hub, because the hub does not have any configuration in memory or in a database or anything. The hub just sits there and waits for somebody to come in and say, hey, I'm here. I'd like to register. So what the node does is during the initial registration request, it takes all of its configuration and sends it as a JSON file to the hub and says, I am registering, I'm here, here's my information. When the node goes offline and after a certain cleanup cycle, the hub goes and says, oh, this node, I have not heard from this node in a while, so I'm going to just delete it. So if you restart the node with a new config, pretty much all the settings that you just did implemented will take effect immediately. You do not need to restart the hub to change configuration on the nodes, which is very useful. In our situation, I try to restart every node after 10 runs. So 10 tests pass or fail, restart the whole computer. And the cleanup cycle is set to 1 second. So that's the unregister if still down after 1,000. No, is it? Yeah, that's 10,000, sorry. 10,000 milliseconds. So if a node is not checking in 10,000 milliseconds, just make it go offline. Technically, if the node goes down but it does not check in 1 second, the hub will still keep the node in memory, but it will not clear it until 10 seconds have passed. If the node re-registers after 2 seconds, the hub will try to dump the memory object and re-register it again with a new object. And there's some gotchas there. I'm having a lot of problem right now with Safari driver, where the Safari node, after a test, tries to unregister, and the hub is not able to clear that Safari's object from memory. And so the hub just sits there and spins. And basically the Safari nodes, after one test, they completely go offline, and restarting the nodes does not help. The only thing that seems to fix it is restarting the hub. So that's a very annoying bug that I'm trying to figure out. Okay, so, and as I mentioned before, whatever proxy you write will only be on the hub. So if you want to affect anything on the node, you have to set up some sort of a listener on the node that will take the command from the hub. The other cool thing though is you can set up multiple proxies, and each node declares which proxy to use at registration point. So if you wanted to have your Internet Explorer nodes behave slightly differently than every other node, then you can have just a different class that's also, instead of setup teardown, it could be Internet Explorer setup teardown. So just slightly differently. And the hub will load that into memory at runtime and execute whatever you're overriding. Next is the prioritizers. By default, hub has FIFO, first in, first out prioritizers. And what that means is that whichever node registered first will always, well, there's a couple of things that are happening with a first in, first out. So whenever, if you have only 3 nodes available, but you have 6 nodes in the queue, 6 test requests in the queue, it will send the new session request to those nodes in the order that they came in. Some people notice that Internet Explorer tests run longer, so they want to start them earlier than anything else. So they wrote their own prioritizer that says, hey, if I have 6 tests that are trying to start, and one of them is Internet Explorer, just put it to the top of the list and make it run first, and then put Firefox and Chrome in the background until the Internet Explorer is done. But by default, the prioritizer class is just an interface, and by default it is set to null. And if you do not specify the prioritizer and it sees that it's null, then it's just gonna ignore it. But if you create a prioritizer of your own and you implement the compare to, you can figure out logic. Okay, this one is more important than this one, and return yes or no based on that. There's some notes not shown here in the prioritizer class of what to do. Like if 1 is greater than 0, then it's this. If 0 is greater than 1, things like that. So you would have to read the documentation. I have not really implemented any prioritizers yet, so I cannot say much about it. Capability matcher class. By default, it checks platform, browser version, and browser name. You can make the capability matcher match something else. If you, by default, say you have Internet Explorer 8, but you want to be able to say Internet Explorer 8.5 or Internet Explorer some other SP2 or some other capability that you want to declare explicitly, you can set up your own capability class and match on that. These seem to work for the most part. I have not had a need to override the capability matcher. And you just have to implement the matches method, which returns true or false. So what happens during a new test request, the hub will go through all the nodes in order that they registered. And they will say, hey, do you match this requested test capability, yes or no? Yes or no, yes or no, yes or no. And the problem with it is if you have 10 nodes and you run 100 tests one at a time, node number 1 will run all 100 of those tests because it will not automatically go to node number 2. There's no load balancing whatsoever. So one node number 4 will never be touched. So that's part of the reason I started to restart after every 10 sessions, because then what it does is it puts node number 1 at the bottom of the list, and now node number 2 now takes all the requests and then just basically keeps switching down, down, down. One of the things that Alex and I were thinking of working with is working with the prioritizer class and figure out, hey, node number 1 seems to be busy, but node number 2 is not. Maybe send the request there. Or if all of the nodes are busy and that node number 1 is busier than node number 3, then let's send the request to node number 3 instead of just keep asking node number 1, because hey, node number 1 is only running 2 tests instead of 3, so let's make it run 3. That's the default logic. So if your node says I can have 3 instances, it will fill up those 3 instances before making node number 2 do any work, which is very frustrating. So in the config, all you would have to do is override by default, it will be the default capability matcher. But whatever one that you write, you just override it at that point. And then the final extensibility part that you can do is the servlets. You can specify any number of servlets, and they will be automatically loaded at runtime when the hub is booting up, and it will give you a unique URL for that servlet that is based on the class name. So if you name it status, if your class name is status or something like that, basically the endpoint will be hub admin slash status. And you can do any response type of that is HTTP format. So if you wanted to do some HTML on the hub, you can override the default console to actually give you more of like a current, in this scenario, the image that you see in the top left corner is actually the current screenshot of the node. And then I was collecting all the information about the node, such as what can it run, how much CPU it is using, how much RAM it is using, how much disk space it has, and all the videos that node ran, and then provide you a link to click on the video so that it automatically loads and you can watch it. The other thing I've implemented is a small JSON response that allows me at any point to ping the node, the hub, and say, how busy are you? How many nodes do you have? How many tests are currently running? And also it keeps history, like this way I can record history when somebody says that session ABC failed for me. I can say, well, session ABC ran on node number 3, so I'm gonna go into that node directly instead of having to open up a VNC window to all 100 nodes we have. So you can play around with those things. We talked about maybe adding some sort of REST API integration with Jenkins. That way, from Jenkins, you can see how many nodes you have and maybe possibly control those nodes, maybe restart and offline and all that other stuff. This is an example of that proxy status that you see right here. And it is default Java servlet response class, nothing special there. And basically you build your response with, you declare what the content type it is, and then in this situation, the status code is 200, and I'm using JSON builder to create pretty formatted JSON from whatever is going on. The JSON builder is really great because you can create a hash map and just throw it at it, and it will make it pretty for you. Next, you just compile whatever you write, all the classes that you wrote, compile it into a jar or a couple of jars, and you add it to the class path. And so in the number 1 is pointing to your jar. Then there's a separator. Number 2 is pointing to the standalone jar, which is the one that you will download from Selenium. And number 3 is just declaring that we need to, you have to explicitly declare that you need to use Grid Launcher, which is the class that the standalone uses by default. That's what the main class calls. But when you add a class path in the command line, it does not necessarily call main, so you have to explicitly say launch the Grid Launcher, and that will go through the commands, and it will actually start the right thing. And then you specify the hub and where to find the config. Okay, so that's enough for the slides. Let me switch over to the IntelliJ. What is my screen doing? There you go. So we can walk through some code. Is that really ugly? Yeah. Okay. Okay, so this is the Selenium core project. This is just the master of it. Oops. So we can everything I've described so far, basically whatever changes you make, you don't have to make your own standalone jar. You just kind of modify it at runtime. That way you can extend it without actually modifying any of the Selenium proper code. Now, if you want to contribute to the actual grid project, you can do it relatively easy by checking it out and then sending a pull request. A couple of in the project structure, it's a little bit convoluted, to be honest. Okay, so 1 second. Java server, open QA grid. So this is the base project where all of the grid-specific classes live. If you need to modify something that is on the node end, you will then go under client. But if you need to modify something on the hub end, this is where it lives. Ignore the buck and the build files. Those are just there for to describe how for the new building system that Simon is trying to implement. Okay. The registry class is the most complicated and evil class I know. It is basically the, okay, hold on, how do I, dot, there you go. It is quite literally the heart of the hub. This is where everything lives. I would say that it would be better done if we could take the registry and put it in a database, and that way it's not in memory. Because it is in the memory, as soon as you restart the hub, any configuration nodes are gone, and there is no state. If we were to put the registry into the database, it would be possible to run multiple hubs or to hot swap and restart a hub without losing all of the information about the nodes and all that other information. So if anybody wants to, if anybody has free time to play around with that, that'll be great. So let's see. This is the capability manager that I talked about, and all of these settings are parsed by the hub config parser, which is a very, very jumbled up and complicated class that tries to take all of the command line flags and all the JSON flags and all the YAML flags and merge them all together. It is the most complicated thing I've ever seen. I've tried to refactor it 4 times now because it's 3 classes that do exactly the same thing, just slightly differently, but quite literally, it's method for method, exactly the same thing. And this config is, it's a nightmare, I'll be honest. This is where the proxy set is the object where it actually keeps track of all the nodes. And if you get it, it's just a set of the default proxies that I was talking about earlier. So this is the one that, the proxies here is the one that we loop through until we find the node that we actually care about. And there's a lot of to-dos in the hub. And never, when you see something is said that it's thread safe, never trust that. It's just there's a lot of to-dos in the grid hub. This section right here is the current pull request that I've submitted to add some JMX support into the hub. This is there for basically what I wanted able to do is connect through JConsole to the hub and say, this node right now is doing something funky. Please offline it until I restart it. Basically how Jenkins allows you to offline a node, but if you say the node is offline, it's not gonna kill and destroy the current build. So basically after the current build is done, offline it. So that is what I'm working on. I'm waiting for all the core contributors to review the changes and add it in. And once that happens, we can start to do something more fun, including keeping track of history, what went where and how, and as the tests are running to kind of get the peek inside of it. If this was in a database, you would be able to just run a couple of queries and figure out, oh, this node is doing this and this node is doing that. But since it's not, and since it's in the memory, JMX seems to be the only option available. So registry is the key one. I can keep going down deeper and deeper, but anybody have questions? If not, I'll go down until you're so bored of it that you're bored of it as I am. So please, if there's any questions. Nope. All right. Let me show you before long. You will need to know how to compile this guy. And that is another fun little project of its own. Hold on, where am I? So the way the whole project is compiled, it's not using Maven, it's not using anything crazy because there's so many moving parts with the project. What they wrote is, you may have heard of it as crazy fun, and it is just a Ruby rake, a JRuby rake task that allows you to compile any of the available ones. So if you do go, or in case of Windows, it's going to be go.bat, and just do -t, it will boot up and it'll give you every command you can do. So you can find how to compile IE driver, you can find how to compile Safari, you can run tests from here. So the one I typically go with is standalone, and it's going to run. And with a -t, it's basically like, give me information. It's like -help. So this gives me the command name and the basic description of what it does. So if you run that command now, it will go and compile everything for you for the Selenium standalone jar, and it will put it into the build folder. So get used to just taking forever to compile. If you're running inside of the IDE, it does not really compile. So, but while that is happening, let me show you. If you wish to debug inside of the IDE, and this took me forever to figure out because I'm not that smart, the Grid Launcher class has this. A lot of really fun flag readings. This is the switch command that you care about. If you want to debug the hub inside of your IDE, so basically you will start up a node somewhere else in another process, and you want to start up the hub just in your IDE, the best way to do it, of course, is to say and just force the switch statement. That way, when you tell it to run, it will start the hub, and it will use all of the default settings, such as port 444 and etc. And if you want to override something, you want to switch the port, you will have to manually go and change it in code temporarily, and then revert when you're done. But this will help a lot if you need to figure out which test slot is not being released after what. So step-through debugging is very useful and very nice. A couple of more classes. I think I have 10 minutes. And again, yes, please. With deploying files? So yes, let me repeat that. Basically, the question is, how does Grid deal with uploading files in a test? There's a special command that you run with the Grid and from your test machine to tell the Grid that, hey, this file, I would like to upload it from that node that I'm testing from. And I believe that it just sends it through HTTP as an HTTP request all the way through the Grid, but I might be wrong. I have not looked at that. But sorry, I don't know how to answer that one. Okay, a couple of more. So in the proxy set, is it proxy? The default remote proxy extends the proxy file method. No, sorry, that's a different one. Remote proxy, there you are. It extends base remote proxy, which implements remote proxy. So each proxy, think of each proxy as a node jar instance. So what you can do on one computer, you can set up 3 nodes individually, and that will create 3 instances of this base remote proxy in memory, and each one of them is different. And each one of those guys has test slots, and those are the max instances of 3 Internet Explorers or max instances of 3 Chromes, and these are the test slots. And each test slot has a state of I'm either open or closed and capability. So each test slot says, yeah, I can run Chrome and whatnot. And so when the registry asks for a new session and goes through every single proxy that is in memory, it is actually going all the way down to the test slot, and each test slot asks it, hey, are you able to run this test or not? If not, then go on to the next one that can find it. So that's the basic layout of it. Okay. Okay, I got 40 minutes. So if you want to deal with the test slot and all that release stuff, it has a lot of threading there, a lot of concurrency, and so just the locking between all the locking and unlocking of the test slots, it gets very confused, especially as I mentioned in case of Safari driver. For some reason, the lock state stays on, and it just when it's going through this logic, because the current session is null, but it still has an internal key but no external key, it automatically says, oh, I don't have to unlock this session test slot, but the test slot is still locked, so it does not actually check if the test slot is locked or not. So it's part of the problem to remember is that the hub 2.0 was written by Francois basically out of in Rush. They needed to have some sort of a grid for the WebDriver project, but they didn't have much time, and so basically it took him a month just to write everything that we call the grid today, which is not that much time if you think about it. And after he wrote it, very few people ever maintain it because it's not documented, and there's nobody seems to show interest. Everybody tries it and then gives up, and nobody actually tries to go in to improve things. So, yeah. And, yep. So, anytime you call test slot to string, what it does is that if the current session is the external key, if it's null, it just says there's no session. And if you ever, when reading through the logs, you will see a lot of that happening, a lot of output going back and forth. No session, no session, no external key, internal key, this, that. So, let's see. Any specific, I guess we still got about 8 minutes and 5 minutes. So is there any specific questions? Because I think I've walked through the basic layout of the grid, and it's mind-numbingly boring, I promise you that, and you will hate yourself, but if you can help out, it'll be awesome. Everybody will love you. Everybody will love you. No? Yes?
Is it better to use multiple nodes or one node with equal number of test slots? What would you suggest?
I would suggest using a lot of nodes that only have one test slot. So if you have VMware, it is better to have 200 VMs that can only run one test at a time. Because the more test slots you add to the node, the more things can go wrong, and especially if in case of video recording, for example, since it's done at operating system level, you see whatever window is on top. So if you have 3 tests running, you don't see what's on the bottom one. But then on top of that, you start to run into focus issues. With Internet Explorer has focus issue, and also Firefox has a focus issue where JavaScript events like on event or on blur do not actually get triggered properly if one of the Firefox windows is on top of another. And there's a couple of workarounds there, but they're not always great. And one of the workarounds is to always, whatever test you're running to, is just say, put me on top, put me on top. And so if you watch the video, it's going to be like all these windows just doing that, fighting for attention, which is not very nice. So if you can have 100 nodes with 1 test slot, instead of having 20 nodes with 100 test sessions, you'll be a much happier person. Yes, sorry. By node, I mean VM. So if you can have 100 VMs versus 10 VMs that can run 20 tests a piece. So, yeah. One of the things I want to experiment with, and I've heard a rumor that it might be possible on Windows to have multiple nodes running in different users. But that one is a little bit trickier. And the other thing I've noticed is anytime you run a node, the best way to start it is with a batch file that you put into the startup folder. Do not run nodes as service. Because when you run a node as a service, Windows will put it into headless mode. And so in headless mode, Internet Explorer and Firefox, they behave differently on Windows than you would expect. And on top of that, if you're using video recording or taking a screenshot of the operating system during a test, the only thing you're going to get is a black screen. So it is better to set up a user to automatically log in and put like a batch file that runs as soon as the user logs in. That way you can restart the node as many times as you want, and the node just re-registers itself. It's like all these tiny little things that are just constantly changing. Part of the reason I started the whole grid extras is to take care of a lot of these things. That way, the first time you run it, it asks you a bunch of questions like, do you want to run Firefox here? Do you want to restart after 10 test runs? And so that it's only one command, and that way you don't have to sit there and learn all of these configs, because these configs, they're quite tricky. There's a lot of competing things that happen. For example, the timeouts, timeout here versus timeout here, they sometimes do what you don't expect them to do. And so the grid extras, the first time you run it, it will create that file for you, and that way you don't have to deal with it. And if you don't like something, you just kind of override it yourself. How much time we got? 1 minute? Okay, that's about it. Sorry, this has not have been a very exciting, but I hope it was very informative, and at least that this is like the first. Now it's been exciting, so there you go. But it's a very first step in actually documenting how the grid works. So, at least we can start with that. And if anybody is very good with writing, because I'm not. If anybody wants to update the wiki, people will love you. All of the, I swear, if you want to ever score favor with any of the core contributors, just go to Selenium HQ and start updating the wiki and all the help documentation. They will automatically send you flowers. So, yep, thank you.